Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes, physical and chemical changes. So these changes we see in our nature. For example, we say the change of melting of ice. I think all of you have tasted ice cream, correct? So that ice cream should be used as fast as possible, correct? Because it melts. There is one beautiful change. Also you have seen milk changing into curds, correct? Is it not? So a lot of changes. The blooming of flower, the blowing of air. Come on, like that you tell some more. Yeah. So these changes can be classified in two types: physical change and chemical change. A change in a substance physical properties is called physical changes, and here there is no new substance formed, only change of state. Is it not? For example, when water is heated it becomes steam, and water when cooled becomes ice. So ice is a solid form of water, steam is the gaseous form of water, correct? So these changes where there is no new substance formed is called physical change. Also you have seen milk becoming curd. Here curd is different from milk. Milk is very tasty, correct? But curd will be little sour, right? So there is a new substance formed, and this change in which one or more new substances are formed is called a chemical change. Can I give one more example? Yeah. Those of you who have grandparents in your house, some of them have the habit of eating betel leaves, correct? So the leaves are green color. The aracanut is somewhat brown in color. The chunam is white in color. So all of them you fold and put in the mouth. You might have seen grandparents eating it. Even you might have tasted also. What happens then? There you see red color. Is it not? What you call tambulam. So red color, your lips also become red, the mouth become red, and there is a new substance formed. When that tambulam is tasted, you cannot find the green leaves or chunam or aracanut, etc. Correct? So that is a chemical change. Now let us see home assignments. The first question is fill in the blanks in the following statements. When carbon dioxide is passed through lime water, it turns milky due to the formation of dash. You have seen lime water? Yeah, lime water will be transparent, correct? So when carbon dioxide is passed through that lime water, it becomes milky due to the formation of calcium carbonate. Okay, that is a chemical. The chemical name of baking soda is, well, the baking soda used in the kitchen or in hotels. The chemical name is sodium hydrogen carbonate, also called as sodium bicarbonate. The other name is sodium bicarbonate, and its formula in chemistry NaHCO3, and here calcium carbonate is, you please note it, in higher classes you know details about it. Okay. Changes in which new substances are formed are called chemical changes. Correct? Now we will see one more question. When a candle burns, both physical and chemical changes take place. Identify these changes. So, burning of a candle. All of you have seen candle burning, correct? Here you find both physical and chemical. Let us see how it takes place. First one is the wax of the candle melts. Here you see the candle, when it burns, the wax comes down. How many have seen candle burning? Okay, all of you. Good. So there are so many interesting things when the burning of candle take place. One of them is melting of wax. And that wax, if it is cool, what happens? It becomes candle again. So it is a physical change. Because there is no new substance formed, the melting wax solidifies on cooling. Even it can make different shapes also. Have you seen it? Seen? Yeah. You can make it to the form of a ink bottle, or you can give it different shapes by using the burning candle. That is a physical change. And also one more thing is the wax of the wick. The wax and the wick of the candle burn and form a new substance of carbon dioxide and water vapor. It is a chemical change. You have seen the wick, this is called wick, black color. So it burns. What happens to the wick? The size of the wick go on decreasing, and you find some gas coming out, that is carbon dioxide, and also water vapor. That is a chemical change, because this burning wick cannot be got again. Okay, so this is a beautiful example of both physical change and chemical change. To give one more example, they ask you to write one more example. Another example of a familiar process in which both the chemical and physical changes take place. The familiar example is burning usage of LPG. What is LPG? Come on, expand. LPG. Liquid. Come on. Petroleum gas. How many of your house has LPG? Almost all. The central government is very liberal. For more than 8 crores of people have been given this LPG supply. Is it not? So there is no more burning with the smoke and all. No more blowing of air and all. So it has become pollution free. So in LPG gas, what happens? The gas burns, and when the gas burns, it will heat the substances which is kept in the stoves. Correct? So there is both physical change and chemical change. Physical change because that LPG which is inside, no, it will be liquid form. It takes the gaseous form. And when it burns, the gas, gives out heat, and there will be a chemical change. So you find both the changes there. Actually, that do you know what is the substance inside the cylinder? Yeah? Anybody? Of course, it's above your standard. It's called butane. You can note down. Butane, butane. That is why it is kept in steel cylinders, very heavy, correct? Because it vaporizes easily. So anyway, it is an example for both the physical change and chemical change. One more question. How would you show that the setting of curd is a chemical change? How many are using curd every day? Not every day, once in a week. Okay, whatever it is, some of you are using every day. Curd is formed from milk. Do you know how it is made? How many have seen it? Or how many of you know it, how to make curds out of milk? Milk is to be boiled. After that, it is cooled to a moderate temperature, say about 25 to 30 degrees Celsius. Then the little buttermilk, namely acid, lactic acid, is added. So then what happens? Next day, there will be what is called a fermentation reaction take place. And the milk, which was very tasty previous night, becomes curd, little sour in taste, and it becomes little hard also, correct? So that is a chemical change because it is a new substance that is formed. Okay, setting of curd is a chemical change. Okay, now let us see today's topic. First about ozone layer, second about rusting of iron, and ways to or different methods to prevent rusting. Lastly, crystallization. So these are the topics we have to discuss today. Okay, so one by one let us go. Ozone layer. What is ozone? Ozone is a form of oxygen. Its formula is, have you heard about ozone? You heard? Okay, some of you might have heard. Its formula is O3. What is oxygen? Oxygen is O2, gas. So this ozone layer it protects us from the harmful ultraviolet radiations, shortly called as UV radiations. Where does it come from? It comes from the sun, correct? So that ultraviolet radiation which are not good for health is protected by ozone layer. It's a natural setting. No scientist or no lecturers or anybody putting there. Natural it is. So what does it do? It absorbs the radiations and breaks itself into oxygen. So ozone breaks up into oxygen and nascent oxygen, which is good for health. So this is Earth globe, and this is a ozone. So this is ultraviolet rays coming up, and this is the layer which protects the Earth. Okay, so this is a very interesting one. But recently you might have heard that there is a holes in this ozone layer. Why it happens? Because of excess of carbon dioxide and pollution gases. So there will be holes. So ozone absorbs this radiation and breaks itself down into oxygen. So the oxygen is very good for health. So what a wonderful arrangement, correct? So we are grateful to the Creator, what we call as God, who is protecting this beautiful earth in which all of us are safe because of the ozone layer, which is acting as a protective layer. Okay, so that is about ozone layer. Now coming to rusting of iron. So you heard about iron, is it? Yeah. Where have you seen iron? Yeah, in window rods. Then the agricultural implements what you use, correct? And even the hammer, all these are made up of iron. So, this is one photo which shows, I think it is in railway lanes or even the concrete shields also. This is how the rusting take place. And please note that this rusting takes place only in the rainy season. Why? Rusting is nothing but formation of the oxide of the iron in presence of oxygen and water. So when this, especially rainy season, what happens? Iron, when it is exposed outside, it absorbs this oxygen and water vapor and forms a layer. Brown layer is formed. That is what is called as rust. Correct? So its actual formula is ferric oxide, Fe2O3, about which you are going to study in class 10. This is the formula. So iron, Fe, oxygen is O2, water is H2O. So ferric oxide, hydrated ferric oxide is formed. There is nothing but rust. Now how to prevent it? Let us see. Okay, how to prevent that rusting. One of the ways is applying a coat of paint or grease. You might have seen the windows, they are painted, correct? They are painted, some of them are white color, some of them are colored and all. Why to paint that windows, the rods? Just to avoid rusting. Another way is putting grease. Whenever there is iron materials, they put grease to it. What does grease do? It will avoid the rusting to take place. One more thing is depositing a layer of metals like chromium or zinc on iron. This process of depositing a layer of zinc on iron is called galvanization. Look at the word here, galvanization. Galvanization is a process of forming coating of chromium or zinc on iron. Okay, the iron pipes we use in our homes to carry water are galvanized to prevent rusting. You might have seen water pipes, correct? What you call as GI pipes. G means galvanized iron pipes. You have seen it? Very hard it is, and it not get rusted. Okay, so this is very good advantage. By using galvanized pipes, water is transferred from one place to another. Okay, so these are some methods in which the rusting of iron is avoided. What are this beautiful figure that represents stainless steel? So this is I can say sink of water, is it not? So these are the steel pipes, what you call. So by using stainless steel, you might have seen it. The tumblers is stainless, the plate is stainless, the vessels what you serve is stainless. Stainless steel. How it is made? It is made by combination of iron with carbon. So iron, its symbol is Fe, then carbon is C, chromium is Cr, nickel is Ni, manganese Mn. So these are the metals and non-metals added to iron. Then it is called as steel. Okay, there is difference between steel and iron. Wherever there is iron factory, there will be steel factory, invariably it will be there. For example, Bhadravati, if you go, we have VISL, Vishweshwaraya Iron and Steel Limited, it's called. The steel also is manufactured. So these are the products of steel. It does not get rusted. However much used, it will not be rusted at all. Okay. So this is the one interesting thing which you are all using in daily life, and to avoid rusting. And last topic for today, crystallization. See, these are called beautiful crystals. And of course, there are two types in that crystal. Some are naturally occurring, some are prepared in laboratory. So crystallization is a process whereby large crystals of pure substances can be formed from their solutions. Okay, this is one type of crystal. Like that, we can prepare some crystals. For example, copper sulfate. The color of copper sulfate? Blue color. A cup full of water is taken in a beaker and a few drops of dilute sulfuric acid added to it. What is sulfuric acid? Also called as king of chemicals. H2SO4. Okay. So water plus sulfuric acid. To this solution, the solution is boiled. Then you add copper sulfate powder. The formula CuSO4. What the color of that copper sulfate? Blue color. So all crystals will have different colors. Here it is blue color, and added till no powder can be dissolved. So we will go on mixing up copper sulfate until all copper sulfate is dissolved in it. Now the solution is filtered and allowed to cool. Okay. Now we can see the crystals of copper sulfate formed. Blue color crystals are formed. So very simple, very interesting. You can try yourself. Even salt also you can prepare in home. Take some salt solution in a china dish, boil it. So what happens? All water vapor will go off. There will be salt deposited on the china dish. So that is the process is called crystallization. And the substance what you get is called crystals. Okay. So a very interesting thing. You can experiment. This process is called crystallization. Here we have copper sulfate, which is blue in color. Similarly, we can prepare ferrous sulfate, it is green in color. So like that, we can prepare different kinds of crystals. Okay, now let us see what Baba says. Sathya Sai Baba Uvacha. 3H. Development of and unity of head, heart, hand. 3H. There is unity. Unity must be there between the head, heart and hand. Hand is for service. Head is for thinking. Heart is for feeling. Correct? So when there is understanding, mutual understanding between these three, all services will have good fruits. That is what Baba says. Thank you.